So in this video, let us try to solve one more LPP problem. It is a bit medium to hard level problem. So let's go through the problem. An employment agency must provide the following laborers for the next 5 months. So they have given the demand, and for each month there is an individual demand for month 100, month 2, 120, and so on. Because the cost of laborers depends on the length of employment. So this is a keyword. The length of the employment determines the payment. Suppose an employee is hired for 1 month, the payment is $100 per employee. If they hire for 2 months, then it is 130. So if you see, if you are hiring for 1 month, it is 100. For 2 months, it is 130. For 3 months, it is 180. For 4 months, it is 220. And for 5 months, if you are hiring, it is 250. So if you are employing one person for 5 months, your cost is 250. Right. Initially itself we are hired and the cost is 250. Suppose you are hiring one employee in the first month, then firing him, so cost is 100. Again hiring in the third month, again cost is 100, then firing him again hiring in the fifth month, then the cost is again 100. So $300 for 3 months. He is working for 3 months, even though you have to pay him 300 because you're hiring and firing, hiring and firing, hiring and firing. But if you employ a person for 5 months, complete 5 months, for entire 5 months duration, you're only paying 250. So you are having a $50 profit if you hire him for 5 months, though there is no sufficient work for the entire 5 months. So this is the crux on which the problem revolves. They say because the cost of the labor depends on the length of the employment, it may be more economical to keep more laborers than needed during some months of the 5 month planning horizon. The same as I explained, hire and fire, than to hire and fire, hire and fire, hire and fire. It is better to keep them over the period, even though there is no sufficient demand. So the table is giving you the cost. They're asking us to solve an LPP and find the optimal solution as to how many members has to be supplied by the agency or how many members has to be employed by the company. So once we come back to the problem, this is just how I have framed it. Here I have started the first just data entry. Don't just get terrified with it. Let me just zoom in. Yes. So this is the cost. First of all, this is the months. Okay, let me do one thing. Let me just start from fresh. So this is a clean slate, right? So first thing is months. There are 5 months. So this is the 5 months. Then the demand. So what is the demand? 100, 120, 80, 170, and 50. 100, 120, 80, 170, and 50. Right? Then cost per duration. Cost is not per month, it is per, if you are employed for a period of 1 month, the cost is 100. If you are employed for a period of 2 months, the cost is 130. If you are for a period of 3 months, it is 180. For a period of 4 months, it is 220. And for a period of 5 months, it is 250. Now we have to form the variable. So how can we form the variable? We have to form the variables with the number of employees who are hired by the company in each month, right? Month one, say, suppose this is the demand, right? This is the demand. You don't know the actual number. Suppose who are actually hired or actually, yeah, let it be actually hired for the duration for the month N1. So N1 be the variable. N1 gives number of employees hired in or number of employees working in month 1. N2 means number of employees working in month 2. N3 means number of employees working in month 4, month 3, N4 and N5 respectively. So this is the number of employees working in N1, N2, N3, N4 and N5. This can be greater than demand. That is what they have said. See here, it may be more economical to keep more laborers than needed during some months of the 5 month planning. They don't know which months is what we have to decide. Then let me introduce one more variable. I hope N1, N2 and N5 are clear. N1 is the number of employees working only for that particular month. Means N1. So only for first month. In first month, how many employees are working? N2 means in second month, how many employees are working? N3 means in third month, how many employees are working? Then Xij. This is one more variable. Xij gives number of laborers. These are laborers. Number of laborers hired in month I. In month I for the duration of J. Means what? Suppose there is X1, 5. 1 and 5. X1 and 5 gives you the number of laborers hired in month 1 for the duration of 5 months. Means this number of laborers are hired in the first month, but they are working for a duration of 5 months. Like that, we have X11, X12, X13, X14, X15. So let me just write them. X11, X12. Maybe I can extend. Let me see. 13, 14, and 15. Similarly, 2. Okay. Then X21, X22, X3, and all. Then let me see if I can just drag them. 3, 5, and 5, 5. Yes. So 1 to X1 means hired in month 1, working for 1 month. X13 means hired in 1 month, working for 3 months. X23 means hired in 1 month, working for hired in 2 months, working for 3 months. So from second month, month 2, month 3, month 4. So until month 4, this X23 workers are working. But if you see X25, this is not relevant because if you are hired in month 2, you cannot work for 5 months. Right, you are already losing 1 month. Entire duration of work is only for 5 months. If you are from 2-5, 2-5 means what? You are hired in month 2, but you are working for a duration of 5 months. Is it possible? From 2, 2, 3, 4, 5, 6. 6 is the count of 5. So X25 is not possible. Then similarly, 3, 5, 4, 5, 5, 5 is also not possible. Same way, X34 is not possible. 4, 4, 5, 4 is not possible. 4, 3, 5, 3 not possible. 5, 2 not possible. Is 4, 2 possible? X42 means hired in the month 4, working for 2 months. So from month 4 and month 5. So 2 months are satisfied. So these are the variables which are involved. So Xij is representing the number of laborers hired in month I for a duration of j months, and these are the entire variables which are going to exist. Now, for month 1, number of laborers who are working in the month 1. Who is working in month 1? X11. So many who have been hired, they are working in month 1. Correct. X12 is working. Yes, they are hired in month 1. They are working for 2 months. X13 is working. Correct. X14 is working, correct. X15 is working, correct. Is X21 working? No, because they are hired in the second month. They cannot work for the first month, right? Then for month 2, number of employees working in month 2, can X11 come? No, because they are hired in month 1 for a duration of 1 month. After 1 month, they leave. So they don't come here. Then who comes? 1, 2 comes. 1, 3 comes, 1, 4 comes, 1, 5 comes, then 2, 1 comes, then 2, 2 comes, and 2, 3 comes, and 2, 4 also comes here. Why? Because they are hide in month 2. These all, whatever be the number who are working, they are all working for month 2. As long as they're working for month 2, we have to count them here. Then similarly, we frame these values 1, 3, 1, 4, 1, 5, 2, 1 doesn't come because 2, 1 is only working for 1 month. 2, 2, 2, 3, 2, 4, 3, 1, 3, 2. Then 1, 4, 1, 5, 2, 3. 2, 2 doesn't come. 2, 2 is over. 2, 4, 3, 1 is over. 3, 2, there is no 3, 3. Then there is 4, 1. And there is 4, 2. So until 4, 2. 5 comes in the next month. Then here X15, X24, X x33, here we have missed x33. So x33 we have missed. 33 is come here because in 3 for 3 months, 3, 4, and 5. Then x41 will not come, x42 will come, and x51 will come. So this is the same. This is the same as you can see here. And I think here we have missed something. X33. X33 is missed. So this, if you see, it is like just like a symmetrical shape. Here, if you see until here it is filled, for this it is filled until here, and this is coming until here. So these are the number of employees who are working for the dependent months. Now the LPP starts. Here it is very simple. So here we'll be getting all the x11, which are the variables x12, x13, x14, x15, x1, x21, x22, x23, x24, x31, x32, x33, x41, x42, x51. So these are nothing but all these variables. Now this is the cost. The cost is nothing but cost for the durations. The duration is the same. Why is it the same? Because here these guys are working only for 1 month, these are working for 2 months, these are working for 3, these are working for 4, and these are working for 5. Similarly, we now only copy until 4 because x2 is having only until 4. Then for x3 we'll copy until 3. So second value giving your duration. Depending on that, we'll just get the values, and this is 100. We have, this is the count. Count is number of employees, number of laborers actually employed for that duration and from that time. Then the optimal cost, which is nothing but the sum product of cost coefficient and the number of laborers who are employed. So this we have got. Similarly, just copy this, and here we are having the N1 to N5, which is nothing but laborers who are employed during those months. LHS, this is greater than or equal to. Why greater than or equal to? The demand has to be met, and the demand employees can be more in a particular month. There can be more laborers than the demand which is required. That is why we have taken them. Then copy this, right click here, and select this button. It will transpose the values from a row. You have got them into a column. This is your demand. This is your symbol, and these initially, this is the coefficient for the equation. This is nothing but the equation. N1 is equal to x11 plus x12 plus x13 plus x14 plus x15. But x12, 13, 14, those values come here. Solver will give those values here. So this is nothing but the coefficient. This is how we have initially solved the LPP problem before the matrix form. If you want to remind it, just look at the first videos, you'll understand. Here we are just writing the coefficients. Before that, let me fill it up with zeros. So unnecessary values are not taking the coefficient. Here 1, 2, 1, 3, 1, 4, 1, 5. So all those I have given the coefficient. Then 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 2, 2, 3, 2, 4. Then 1, 3, 1, 4, 1, 5. Then 2, 2. See, 2, 1 should not get. 2, 2 only should get. Then 2, 3. Then 2, 4. 3, 1, 3, 2, 3, 3. Then for N4 it is 1, 4, 1, 5, 2, 3, 2, 4, 3, 2, 3, 3, 4, 1, 4, 2. This is why I have created this matrix. So it will be easy for writing the coefficients. Then for x15, 2, 4, 3, 3, 4.2 and 5.1. Now what is your LHS? LHS is the coefficient, is the equation, which is nothing but the sum product. Sum product we have seen earlier. If you don't remember it, just look at the first video. Then for this is constant. Only these values change as we go through this. So we just press function F4. So this is constant. Now we simply drag it. In order to differentiate these values, let me conditional format them. Greater than 0, highlight it with green. So this is how see, if you look at this value, this is also like a triangle, right? The same triangle is going on decreasing. This is the triangle here. Then this value, this triangle, inverted triangle, or the L shape, inverted L shape, whatever you want to understand it. Then that's all. We have formed the equation. We have put the constraints. These are the constraints. The employees who are actually, laborers who are actually employed should be greater than or equal to demand so that the cost is minimized. Now let's simply go to solver, data solver, reset all. And this is your objective function. Minimize it by changing values. These are your values which have to change, right? Then your constraints, which are nothing but these, greater than or equal to the demand. Okay. Then simplex LP, simply solve. Solver found the solution and the cost has got out to be 32,100 is the total optimal cost which you have got. And let me also conditional format this thing. Highlight the cells greater than 0, put them yellow. So now it will be, if you are unable to understand until now you will understand it once again. If you select manually, they are saying hire 50 laborers at month 1 for a duration of 4 months and hire 50 laborers from month 1 for a duration of 5 months. Then hire 20 laborers in month 2 for a duration of 3 months. Then hire 50 laborers in month 4 for a duration of 1 month. Let me just show you manually. Now N1, N2, N3, N3, N4, and N5. N4 and N5. In month 1, see this one, how many X14, X15, X23, and X41. Only these are giving us the values, right? X14 is giving 50. 1 means higher in month 1 for a duration of 4 months. So 50, 50, 50, 50. Here, no value, 0. 15 means from month 1, higher in month 1, keep them until 5 months. Keep them for a duration of 5 months. How many it is giving? See value 50. So again 50, 50, 50, 50, 50. Now 2, 3. 2, 3 means higher in the second month for a duration of 3 months. So from second month, 20, 20, 20. See, second month for a duration of 3 months. Then 4, 1, 50 for 4, 1 means from 4 for 1 month, 50. Remaining are 0, 0, 0. Now, just so the visibility is clear, it is always good to highlight greater than 0. This time highlight rate. So this is the contribution given. Now see the total sum. Let me just extend it. Now look at it. Month 1. Also let me paste the demand. So this transposed. Now you see. Demand is 100, 100 is met. Demand is 120, 120 met. Demand is 80, 120 are kept. Why? These 120 are retained for the next month, so the economies of scale for the employment is utilized. Next 170. 170 is your demand. Where did we go wrong? Yes, we did not write the 41. See, 41 we did not enter. 41 is also giving 50 employees. 41 means in the fourth year for a duration of 1 month. Those 50 have come here. Those give the total 170. Then we have removed all of them, 50 and 50. So I hope this is clear the explanation. This is one way. Double matrix means x11, 12, 13, 212, 223. Those who have done engineering might be familiar with this. 1213, 2123, 2324, 3132 and all. So this is one more way where you can solve the problems. If you have understood it, it is good. If you have not understood it, try to rewatch the video. That's it for this video. Thank you for watching.